In this demo, we'll improve our code by using our freshly created property mapping service in a reusable to-be-created extension method. We will name that extension method apply_sort. We're ordering via our repository, so that's where the method will be called from. Seeing that apply_sort method will need our property mapping service, let's inject a property mapping service in our repository. We do that via constructor injection. With that, we can then get our authored property mapping dictionary. Let's import the necessary namespace here. And then let's already write that apply_sort method we want to apply, but still have to implement. So this is what this method will look like. It will replace the manual checking and ordering we had in place up until now. So let's already get rid of that too. There we go. Okay, so now we can write that apply_sort method. Let's add a new class to the helpers folder. It will contain extension methods on iQueryable, so let's name it iQueryable extensions. Seeing we will write an extension method to it, we need to make the class static. Let's add one method to it, apply_sort. It works on an iQueryable of t, returns an iQueryable of t, which is the source but sorted, and it accepts the order by string and the mapping dictionary. Let's import the necessary namespace here. And as we are going to be using dynamic link, let's add a using statement for that as well. So the first thing we want to do is check the input. If the source or mapping dictionary are null, we throw a new argument null exception. If no order by clause has been passed through, we can simply return the inputted source. Once all of that checks out, we can start creating our order by string. So we create an empty string variable, and then we split the input. The input is order by. Seeing what's inputted is separated by a comma, we split it and store that in an order by after split variable. It's that variable that we can now run through to apply each order by clause. So we run through the order by after split array. We store each item in the order by clause variable. First we trim it, as it might contain leading or trailing spaces. If the sort option ends with DESC, we order descending, and otherwise ascending. Then we want to remove ASC or DESC from the order by clause, so we get the property name to look for in the mapping dictionary. Once we've got that, we find the property name in the mapping dictionary. What we're looking for is a key with the property name. If it isn't found, we throw an argument exception, because we do need a mapping to be able to continue. If the key exists, we get the value related to the key. That value should be a property mapping value. If it's null, we throw an argument null exception. That's a bit cleaner. One last thing we have to keep in mind is that the sort order can potentially be reversed. So we check if that is the case. And if it is, we switch the order descending variable. After that, we run through all the destination properties, and we construct the final order by string. Once that is done, for each item in the splitted order by string, we can apply the full sort expression. We do that by calling into order by, passing through the constructed order by string. And that should be it for this method. Let's save this and let's switch back to the repository. The apply_sort method now resolves. Let's give this a try. First, let's try getting all the authors again. These come back sorted by name, as that is the default for the order by parameter. So, were we to add that explicitly, like this, we should get the same results. And that is indeed the case. Then let's try ordering by name descending. This should return the authors ordered descending by name. And that is indeed the case. So far, so good. Let's continue. Name was a field that translated to two properties on our entity. Main category, on the other hand, was a direct mapping, one-on-one. So let's see whether that works as well. And indeed it does. The authors are sorted by main category in ascending order. If we add DESC, we should see the reverse, as is indeed the case. And let's combine that with that other special field we had, age. So we now order by age first and main category descending second. And there we go. The authors are now nicely ordered by age, followed by main category in descending order. So far, so good. But not everything is okay. Let's try combining sorting with paging. So this query should order by name descending and give us back the second page with a page size of 5. So we should get back 2 authors. And that is indeed the case. These are the 2 last authors from the list when you order them by name, descending. But let's have a look at the headers. We see a previous page link here, and that's okay, but that previous page link doesn't contain the sorting order anymore. So were we to navigate to it, we would lose our sorting order, and that can't be right. Let's fix that in the next demo. In this demo, we'll make sure our order by clause is available in the pagination links. And we kinda know how to do that already, as we did the exact same thing for the filter and search query previously. Let's switch to the authors controller. Now let's navigate to create authors resource URI. Here we need to add the order by clause. And we do that for all 3 of our generated links. Let's save this and let's give that a try. Let's try that previous request again. We still get back the second page with the last 2 authors, ordered by name descending. And if we look at the previous page link now, we see that it contains an ordered by query string key with value name descending. So let's give that a try. Let's escape it. And let's send this. And there we go. We get back the first page of 5 authors ordered by name descending. Lastly, let's try an invalid request. I've got a request lined up here that's going to try and sort by date of birth. That obviously shouldn't work. There isn't a mapping defined for that, and moreover, the DTO does not contain a date of birth property. It doesn't work, so far so good, but we get back a 500 internal server error. Remember that when the consumer of the API makes a mistake, the consumer should get back a level 400 error? Well, in this case, the consumer made a mistake. Invalid input was provided, so we should get back a level 400 error. In other words, it is not because our code works that we're there yet. Let's check out how we can fix this in a way that adheres to the HTTP standard in the next demo. What we want to do is add a method that checks for invalid input. We can then use that result in the getAuthors action to return the correct status code. So when is an order by value invalid due to a consumer mistake? Well, we decided on that before. It's invalid when they ask to order on a property for which no key in the dictionary exists. That doesn't mean that if that checks out, that other issues might not arise. For example, we might introduce an unwilling bug, like make a mistake in a mapping, or provide the wrong mappings to the apply sort action. That can result in an exception, or it might pass without us noticing. It can be a bug. But those are mistakes of the server, or rather of us, the developers, and not of the consumer of the API. So we need to check if, for a given string of fields like our order by string, there is a valid mapping dictionary that contains mappings for those fields. So the property mapping service sounds like a good place to add such a method to. The method should return a boolean that will be true if all checks out. Let me paste in the implementation so we can run through it. We get the mapping dictionary by calling getPropertyMapping, passing through the source and destination types. Then we split the inputted fields and run through them. We trim them so leading and trailing spaces are ignored, and we also remove everything after the first space. That'll make sure that if the fields are coming from an order by string, ASC and DESC are ignored. Then we look for the property mapping with that field as key in our mapping dictionary. If the key is not found, we return false. If all checks out, we return true. And that's already it for this method. Let's add it to the iProperty mapping service contract. There we go. And then we can start using this in the authors controller. So let's switch to that. And let's inject an iProperty mapping service. We can again use constructor injection for that. In the getAuthors action, we then call into this method. And if no valid mapping exists, we return a bad request. Let's give this a try. And let's send the request from the previous demo again. And this time we get back a 400 bad request. So far so good. And then let's combine all of this. In this request, we are asking for the first page of authors with a page size of 2, ordered by name, which contain an A in any of their string values and have rum as their main category. Doesn't seem to be many authors like that in our dataset. So let's try singing. And there we go. Apparently Arnold is the only one that matches. And with that, we have just implemented automatic sorting on all fields. It wasn't easy to add, but all in all, it also wasn't that much work. And with this, we now get sorting functionality on all fields, ascending and descending and in order. Also, this piece of code is reusable for other resource collections. Interesting fact is that we can use the same technique for filtering if we want to allow it on all fields. We could use the mapping table to find out how a property on a resource maps to the underlying store and use dynamic link to create the where clauses. So this approach is pretty flexible and can be used for more than just sorting. Anyway, with that we know how to sort. Let's have a look at the module summary. When implementing sorting functionality, it's important to keep a few things in mind. Collection resources are typically sorted on multiple fields. Often, the sorting direction has to be taken into account. Sorting should only happen on resource fields and not on fields that lie beneath that layer. That requires a bit of plumbing, because otherwise you will end up with a set of large switch statements. We solved that by writing a reusable mapping service and a reusable apply sort extension method. The order by parameters must also be returned in pagination links, and errors related to wrong input are consumer errors and should thus be returned as a level 400 error. For example, a bad request. There's another piece of functionality that is sometimes supported by RESTful